Hello, I am Michael Wallace, a student at the International Center for Creativity, and today I am proud to present to you the Eagle, a multi-tool designed for firefighters by firefighters. So, a bit about myself. During my sophomore year of college, I decided to get my volunteer firefighter certification. This process took about a semester and I had to complete 2 state tests before becoming certified. Over the course of the following years, I gained some other certifications in the first responder industry. Some pretty basic, like Intro to Incident Command, CPR, First Aid, but some more complex certifications, such as Intro to Hazardous Materials, Radiological Emergency Management, and Animals in Disaster. I know you came here expecting a capstone project. It was more of an entrepreneur's journey. I've been working on this project for well over a year, and this was a project I was working on well before I knew it would be my capstone project, and I will continue to work on it well after I present my capstone. So let me run through a quick outline of this presentation. First, I will do an introduction, discuss some of the research I conducted, walk you through a journey map, state my problem, walk you through the design process, show you how I created a functional prototype, show you some of the field testing I conducted, as well as talk about the business I'm trying to start, Wallace Design Co., and wrap up with a quick conclusion. I created this Gantt chart to show you how far along I am in the process. As you can see, I broke down this entire project into a couple different categories, and for some of the categories I'm almost complete, and for others I'm in the middle, and some I'm pretty much just getting started. Even though I've been working on this project for over a year, it is a rather long process and I still have a lot of work left to do. Initially, when I started this project, I expected that the path would be something as you can see. I would exactly know the finish line. It will be straightforward and clear to me at all times. Occasionally, I would take a wrong turn here or there, but I would pretty quickly be able to complete this project. In actuality, the process was more like this. Really confusing, really messy. I didn't know what the goal was for most of the time. Sometimes I was working backwards or didn't even know where I was headed. But that process allowed me to create a great tool. As any entrepreneur would know, getting a product to market is a lot of problem solving. And these are some of the problems that I had to overcome, including corrupt files from my flash drive, 3D printer failures, emails and phone calls that weren't responded to, non disclosure agreements, limited patent knowledge, just to name a few. Now, let me tell you about some of the initial research that I did. I started with academic research, reading National Fire Protection Agency reports and other academic journals, reading departments' SOGs, Standard Operating Guidelines, and SOPs, Standard Operating Procedures, as well as after action reports to gain important data about this project. Some of the critical data that I gained from this research was that on average 100 firefighters die in the line of duty per year in the US alone, and the number one leading cause of deaths was a result of overexertion / a cardiac event. As you can see in this photo, firefighters are expected to carry over 100 pounds of gear on their person. This particular firefighter is carrying over 130 pounds of gear. The heavy physical exertion required to carry all this gear was linked to a 60% chance increase for sudden cardiac events. Also, throughout my research, I realized how false TVs and movie shows are about firefighters. When you call, you usually expect something like this: a number of firefighters showing up with a number of trucks within seconds of the call being placed. That's what TVs and movies lead you to believe, but it's not realistic. In actuality, you'll probably get something like this. 80% of the fires in the US get an initial crew to the scene within 11 minutes. However, Initial crews are usually only 2 to 3 firefighters. That's really difficult for 2 to 3 people to put out a structure fire, and it may be a long time working before anyone else shows up. After conducting this academic research and gaining this insightful data, it was time to get my boots dirty. I went on ride-alongs with some fire departments to actually gain some real-world experience. Not only did I go on emergency calls, but I also did some training with them, including the aerial, which is over 100 feet in the air. We were able to go up in the aerial basket and use some of the master streams, which are massive water cannons. Now, I'm going to give you a quick journey map through what it's like to be a firefighter when responding to a structure fire call.
Matthew Mill Road, Cross Street, Iroquois Trail, structure fire, stations 2.
So initially they get a call with some basic information and the location of the emergency. They quickly rush to get geared up and en route. As I said before, it can take a very long time for the firefighters to arrive on scene. Once they arrive on scene, they grab their helmet and gloves and do an initial scene size-up, determining what the situation is and if they need any additional resources. Now, they are grabbing the hose and making an initial push on the structure, trying to extinguish the blaze. Once they get a good handle on the fire, they determine that they need another tool, so the firefighter starts walking back to the truck. As you can see, this is taking a very long time. The firefighter is already exhausted from the work he has already done. The firefighter is grabbing two tools, the pike pole and the drywall hook. Each of those tools weighs about 10 pounds, so he is adding an additional 20 pounds of gear that he has to carry. Once he gets back to the structure, they determine that they need to make entry through a window and search for any additional fire inside the building. As you can see, he's having a little trouble breaking through that support beam. But once he makes it into the structure, he starts pulling down the ceiling to search for fire in the voids. As you can see, when working a structure fire, there is often little to no visibility. He then determined that he needed more hose and started to head back out to the truck to grab an additional hose line. I can personally attest that the hose is the most difficult tool that firefighters have to use. It weighs a lot. You have to flake it out and make sure you can go around bends. It causes a lot of friction on the ground, and once filled with water, it gets extremely heavy. We would be pushing hundreds of gallons of water through this nozzle per minute, and each gallon weighs about 8.3 pounds. So once the firefighter re-enters the structure, as you can see, the fire has grown much worse, just within the time it took the firefighter to go to the truck and come back. This is very common as fires can spread extremely rapidly in modern structures. The firefighter is now extinguishing the blaze and getting it under control. Soon he will call command to give an all clear.
Control 3, you the fire under control. Stop the clock.
Copy. Fire under control, stopping the clock at 2:41.
So, as you can see on this journey map, the first step is the tones drop and we get the call with some basic information. They go en route, and as I said before, it could take a while before they get to the scene. Once they're there, they do an initial size up and call in any additional resources they think they need. as well as starting to operate the structure fire. Step 4 is making initial entry. This could be either searching for victims or for searching for fire. Then step 5 is grabbing the necessary tools you need. And then step 6 is remaking entry into the structure. As you can see, the steps 5 and 6 have a circular cycle that causes problems because by the time they're making reentry, the fire could have grown much worse. So after going through this process, I started narrowing down on the problem that I was trying to solve. How do I reduce the number of tools firefighters have to carry? And how do I reduce the number of trips a firefighter has to make from the structure to the truck? Basically, how do I reduce the amount of gear that firefighters have to carry and how to save them time from running back from the structure to the truck? So now let me show you the design process that I took to get this project completed. Initially, I started looking at the 4 most common hand tools used by firefighters: the Halligan, the axe, the sledgehammer, and the pike pole. Then I asked, can I design one tool that will save time and weight by combining these 4 hand tools? Once I knew that was the problem I was trying to solve, I started sketching, and that sketching quickly went into CAD so I could render it out. Once I was in SolidWorks, I was able to create some 3D printed prototypes, making small corrections on my design. And I continued to do that. By the prototype number 8, I was thinking, okay, this is probably complete. It should be all set. But in actuality, there were some more problems I had to fix. So I had to create some more 3D printed prototypes. And there were still more problems, so I had to keep going, printing more and more of these prototypes until the design was just right. After the design was complete, I put it back in SolidWorks and started running some stress test analysis to determine the strength of the tool. The worst thing that could happen is that the tool is too weak and would break when a firefighter needs it the most. So I was able to run some stress test analysis on various parts of the tool, determining its strength. And this tool is extremely strong. It can take over thousands and thousands of pounds of force applied to it in almost any direction. And it doesn't deform, as you can see on screen. It actually would only deform less than a millimeter. The reason it's deforming on the screen is because engineers need to understand where the force is being applied. In actuality, it would not bend like this. So once I was able to complete some stress test analysis throughout the design, I was able to come up with this, my final design for my tool. As you can see, it combines the axe, the sledgehammer, the adze, and the pike pole. In this render, you can see the adze being used to breach open a front door. In this render, you can see the tool being used as a sledgehammer to break up a masonry wall. Once I had my final design, I determined to create a functional prototype. Initially, I went to blacksmiths and asked them if they could create this. After talking with a number of them, they said it would be really difficult to build, take a very long time, and a lot of money. So I thought to myself, how could I make this cheaper and faster? Well, then I started thinking about CNC machining, and I thought that it could be made there. So I started contacting companies that do CNC machining, and they said their lead times for 16 to 18 months and it would cost thousands and thousands of dollars. So that was time and money that I didn't have. So I kept thinking to myself, how can I build this? How can I build this? And it occurred to me, what if I create this in 3 separate components? That would reduce the time it would take and the cost. Then I thought, well, I could probably create some of the components myself. Some of them are pretty simple. So if I have access to a manual mill, I could probably create some of these. So I started asking around if I could have access to a manual mill, but I couldn't get access. So then I determined to use the tools that I have on hand and create a hack model. This is actually where I determined to create a functional prototype. This would allow the design to be tested with the same function, but it would not have the same aesthetic as my design. Once I determined that this was cheap enough to actually be able to raise some money, I started a GoFundMe with the goal of raising $1,000 in order to create this functional prototype. Luckily, through some generous donations, I was able to raise almost $535, which gave me a budget for the project. And a Halligan. I ordered a Harbor Freight splitting maul and a Halligan. However, the day before I was going to go to the shop and start creating this prototype, the Halligan arrived and it was too small. I couldn't use it for my prototype. So within a couple hours, I had to solve this problem. I was thinking to myself, what could I do? What could I get that could create this functional prototype? So I ran over to Lowe's and grabbed a splitting wedge. It was about the right size and shape, and it was the correct material. So once I got to the shop, I used some of my 3D printed prototypes to lay out the design on the pieces of metal. So I started to cut and hack away at the splitting wedge. This cut you see took over 2 hours to complete. I knocked out the fiberglass handle for the splitting maul, and I got this cylindrical piece of steel to fill that void. However, that hole is not a perfect cylinder. It's actually an ellipse that's tapered. So I took a lot of time and effort to grind that cylinder down to be able to fit that hole. Luckily, after many hours of grinding and attempting to fill that hole, I was able to successfully plug that hole. And I was able to successfully turn that splitting wedge into an adze. Once I had all the components completed, I brought all these parts to a professional welder. I knew that each individual piece was strong enough, but the joints between the components was the weak spot. And I didn't want to give firefighters anything that wasn't strong enough. So I determined that a professional welder is required to weld the 3 components together. And this is my final functional prototype. Now, let me take you through some of the field testing I conducted.
Test 1 was simulating chopping through a wooden roof in order to vent a fire. Test 2 was testing the sledgehammer, simulating breaking through a masonry wall.
Two, one.
Test 3 was using the adze to breach a steel door in a steel frame.
Everyone ready?
Ready.
3, 2, 1.
Let me tell you about the company I'm trying to start based around this tool, known as Wallace Design Co. Initially, I was thinking that I would manufacture the tool myself. However, I created a quick business model canvas, which tells you the key partners, activities, resources, some of the cost structure, etc. of starting a business. And Once I was able to complete this, I realized that I would have to have a lot of different partners. It would cost a lot of money to get this started, and I would have to overcome a number of problems. So then one of the professors recommended a licensing agreement with the manufacturer for my design. So I created a business model canvas for that. And as you can see, that was able to reduce a number of problems that I would have to solve. Look at the startup costs for a licensing agreement. This is the expected startup cost for a completed design that has a licensing agreement with a manufacturer, and that total comes to $21,500. Then I looked at the profit margins, not only for myself, but also for the realtor and manufacturer. How we determined this was we kind of worked backwards, looking at the cost of Haligans on the market currently, and determined the profit margin that each person would need per unit. So what's next? As I said before, this project is not done just because I'm presenting my capstone presentation. Within the next 60 days, I hope to be able to go to a fire academy and conduct further field testing with fire instructors and more firefighters. After that is complete and I know the functional prototype works well, I hope to raise an additional $600 to create a more accurate and refined functional prototype. Once I have this refined prototype that is identical to my design, I will conduct additional field testing to make sure my design doesn't have a hidden flaw. Once that is complete, I would start negotiating the licensing of the design to a manufacturer. Here are some of the sources. Thank you for listening to my presentation. If you would like further project updates, please follow the upper QR code that will take you to my LinkedIn profile where I will post continual project updates. If you would like to support this project further, you can follow the bottom QR code which will take you to my GoFundMe page. Thank you.